This is Hacker Public Radio episode 3339 for Thursday, the 20th of May 2021. Today's show is entitled Linux Inlaws S01E30. Politicians and Artificial Intelligence Part 2 and is part of the series Linux Inlaws. It is the 30th show of Monochromic and is about 58 minutes long and carries an explicit flag. The summary is part 2 of the miniseries on deep learning, politicians and other approaches to intelligence or not.
This episode of HPR is brought to you by archive.org. Support universal access to all knowledge by heading over to archive.org/donate.
This is Linux Inlaws, a podcast on topics around free and open source software, any associated contraband, communism, the revolution in general, and whatever fancies your tickle. Please note that this and other episodes may contain strong language, offensive humor, and other certainly not politically correct language. You have been warned. Our parents insisted on this disclaimer. Happy Mom? Thus, the content is not suitable for consumption in the workplace, especially when played back in an open plan office or similar environments. Any minors under the age of 35 or any pets including fluffy little killer bunnies, your trusty guide dog, unless on speed, and cute T-Rexes or other associated dinosaurs. At the beginning of the episode, you will notice a reference to quantum computing, which may seem to be out of context for some of our listeners. For a resolution of this mystery, check out the outtakes at the end of the episode. This is Linux Quantum Physics Inlaws, Season 1, Episode 30, TensorFlow and such. Martin, good evening. How are things?
Hey, Chris. Things are great and wonderful.
Perfect.
Always. How are you?
Can't complain. Now that the moolah is rolling in.
Is it? Oh, right. The cartel's coughing up finally, are they?
No, but apparently the company that I'm working for has filed for an IPO.
Have they? I thought they just had some funding.
Well, no point in stopping now, right?
How does that work? Hang on. You're getting people to fund you and then...
That's the plan, I think, yes.
Not sure there's much logic in that. But anyway, fair enough.
Since when features logic into IPOs?
Well, if you're listening, Offer and friends, feel free to send me some more shares. Yeah, for all my hard
Offer on the off chat. You're listening. Yes, send me some additional shares too.
Yes, and where's the open source support for Redis in Redis Labs?
Okay, but Redis is not the subject of tonight's episode, but rather something called neural networks, as perhaps avid listeners do recall.
Specifically, no?
Say again?
Framework specifically?
Yes, as avid listeners will recall, there was a part 1 where we basically tackled the foundation, and this is part 2 now, of a 27.5 part series on machine learning, deep stuff. Crap.
Our friend Ken did ask for more contributions, didn't he? So.
Yes. He also sent feedback, but we want to tackle this in a minute or two.
Oh, yes.
No, jokes aside, this second part is actually building on top of the first part. Now we're going to actually tackle some way more concrete stuff, like actually frameworks that implement neural networks.
Indeed. Like
So, Martin, why don't you give us a quick recap of episode 1?
episode 1, oh, it's ages ago, isn't it? It's
For those few listeners who missed out on it.
Okay, episode 1 was really the basics of how neural networks work, right? So, which, not everybody wants to dive into because that is a lot of work, and why not reuse what other people have built already in magnificent frameworks like PyTorch and TensorFlow.
Indeed. So before we go into the nitty-gritty details, maybe we should do a little bit more of a detailed recap of what episode 1 was all about. Essentially, we spoke about... You want to give it a crack? Yes.
Again.
Yes, but for those people who do not want to spend another 3 hours on the director's cut...
Well, they have to, really. Sorry, that's the prerequisite for this episode.
Yeah, but that's not very user-friendly, Martin, is it?
Right,
I mean, Martin, this is what I told you during the marketing brief about a week ago. You have to pay attention to the needs of something called the listeners.
I think you watched too many popular series, haven't you, where they have to recap the previous one. Do a teaser of the next one afterwards.
Martin, quite a few people from America listen in. Donald, if you're listening to this,
yes. Hello, Americans.
We're still fans.
Yeah.
So you have to take our listenership into account. So bear in mind, yes, some people will have not the attention span that we do. Some people will even have a longer. Yes, some people will have even a longer attention span. Grumpy old coders, if you're listening, you know to what category you belong to. We must do another episode with them. That was actually very, very good. I don't know. I missed them. Anyway, doesn't matter. Let's do a very quick extended recap of the first part, and then we can go into the details. Okay. Neural networks essentially are neural networks in terms of you have neurons, which essentially can be represented by a mathematical function. They take input values, they produce output values, and the magic actually happens inside that neuron in terms of how you model the function.
Hang on. There's no such magic, and there's no such thing as magic in computer science. You know this thing.
I've done a PhD in computer science.
Have you been in sales for a few years, perhaps?
Okay, Martin.
Sorry, carry on.
Why don't you explain the magic then?
No, I just said there is no such thing as magic in computer science.
Well, there is, but subject for another episode. Okay, no jokes aside. The idea is essentially to model the human brain. And as people tend to simplify things because how a human brain works is much more complicated than simple artificial neural network is capable to model, they simplify things. So essentially, the way it works is that a neuron that is simple, the actions of a neuron are represented by a model. So it's a simple mathematical formula. It's sums, multiplications, all the rest of it that take input values, produce output values. And the idea behind such neural networks is that you have a multitude of neurons being interconnected. And that multitude then is multiplied by so-called, or categorized rather, into so-called layers. The neural network functions as follows. The idea is that you have a training phase where you essentially teach the neural network how it's supposed to behave, like giving input values, the expected output values, and based on the output of the multiple layers of neurons, you modify the individual parameters that are attached to these functions.
Yeah, you could call those connections, really, couldn't you?
Exactly, and you may also modify the connections if you want to be really close to something called the human brain. Because what the neuron brain actually does, it modifies the interconnectivity between neurons all the time, and this is something that we call human learning. Yes, to oversimplify things just once again, after this training phase, you should have a model in terms of you have neurons and you have values or parameters associated to these neurons that you can then use to essentially put the thing into production in terms of you give it some real input values and then the neural network does its magic in terms of recognizing speech, identifying patterns in an image, and all the rest of it. Because at the end of the day, a neural network is just about pattern matching on the very sophisticated level, granted, but that's where the magic stops.
Yeah, so then this phase is normally referred to as inference, isn't it? But,
and now the second part of this 27.5 part miniseries is actually on how to put this into a bigger context in terms of, now that you have the theoretical foundations, how you can actually put this into production in terms of how you can apply this to the real world. Because needless to say, if you want to program a neural network, you don't want to sit down and just program the neurons themselves, program the functions running inside the neurons, and feed them the input values, and then do the inference phase yourself and all the rest of it. No, you want to use some model that is already out there working, and that's exactly what these frameworks that Martin just mentioned, PyTorch and TensorFlow, are all about. And the hint really is in the name of TensorFlow, because also PyTorch does it the same way. The idea behind the interconnected neurons is passing around values that are then used to carry out the functions of this neural network. And funny enough, these values are easily captured, efficiently implemented, and easily modeled as tensors.
Maybe you would like to explain to the uninitiated what a tensor is?
It's quite straightforward, actually. It's an algebraic mapping of n dimensions. There you have it.
Okay, fair enough.
Of course, that's oversimplifying things.
Well, no, it's a multi-dimensional array, really. Put it that way.
This is one of the expressions of a tensor. Yes, in its simplest form, actually, a tensor represents essentially a mapping from one algebraic structure to another. Think of it like a vector being mapped onto a different vector, and the mapping is actually the tensor itself. Now, this simple mapping is also called a degenerated tensor, because it simply takes one vector and maps it onto the other. The interesting bit, basically, is if you have whole fields of algebraic structures like matrices and so forth. And this is the reason why tensors are actually quite good at capturing these relations, these interconnectivity issues. So if you look at popular frameworks like TensorFlow, and actually the hint is in the name, and PyTorch, the basic algebraic abstraction would be a tensor, in terms of this is how you model your neural network on the very lowest layer.
Okay, yeah, thank you for that explanation. Where were we with this anyway?
We wanted to explain how TensorFlow and PyTorch essentially do it.
Well, why don't we cover a little bit about why there is more than one and what happened before?
Absolutely, Martin.
TensorFlow and PyTorch. I don't know where you are in your context, but so by all means, if you are in the middle of something, carry on.
No. I just laid the foundation, Martin. Give it another shot about the non-mathematical background to this.
Uh-huh.
I mean, needless to say, I don't want to steal your thunder, so just go right ahead.
Hang on. You're confusing.
Martin is lost. Martin, why don't you bootstrap?
Chris.
Yes. Why don't you bootstrap the TensorFlow that is you, and then you can start all over again?
I don't think people have a reboot function, do
they? Another implementation flaw, okay.
Yeah, I think so. 5, 6, 7 years ago, people started building various frameworks. I think Keras is one of your favorite now. Don't know how long that's been around, but in the last, 5 years, TensorFlow came out first to try and get a bit more of a standard to this. And then about a year later, you will do you know the background of PyTorch, by the way?
Probably not as well as you do, so give it a shot.
Well, I mean, it's the original, the pre or what PyTorch is based on is Torch, right?
That's a library, yes.
Which was written in Lua, which you may be familiar with. You familiar with Lua, Ben?
I'm afraid, yes.
What would you say the attributes of Lua are?
OpenWRT uses it as a basis for a web framework called Lucy, which is essentially the web-based GUI for your router management. And there's also this crazy, it's Sicilian, Salvatore, if you're listening, no offense, who had this idea of providing a script-based interpreter on top of a very popular NoSQL database called Redis.
Indeed. Anyway, so, I mean, Lua is not really known for its wide adoption, I would say, apart from... No,
hang on, Martin. Does prosody ring a bell?
How much?
Prosody.
Yes, it does.
And this is actually written in Lua, believe it or not.
Yeah, but if you compare it to other programming languages out there, then it's a little bit low down the...
Well, prosody would be one of the
adoption
most popular XMPP servers on the planet.
Yes, but that's not a programming language, is it?
No, it's just an XMPP server. That's correct. It just happens to be written in Lua. That's all.
Good. Glad we can agree on that. Anyway, so yeah, Lua is I don't know. I mean, obviously, I saw Lua for the first time. Well, not obvious, but first time I came across Lua was with Redis. Don't know about you, but. So for many people, Lua is pretty unknown, right? And is not that well known for its modularity or widespread adoption amongst the programming fraternity.
Unless you take a peek behind the scenes, because Lua, like Redis, is basically present in pretty many areas.
Yes,
as a matter of fact, I came across it first basically when I installed my first OpenWRT instance on a router.
Yes, but you didn't program in Lua, did you?
Not then, no, but later.
No. Yes, that would have been in your Redis days, I imagine?
Slightly before.
Okay, no, fair enough. Anyway, so yeah, some people, or many people, are not that familiar with Lua, and so the founders of PyTorch thought, oh, hang on a minute, everybody's using Python. Why don't we wrap that around Torch and create PyTorch?
And PyTorch was born, yes.
So, why don't you tell us where TensorFlow came from?
Google.
Uh-huh.
No, the idea was essentially to provide a low-level infrastructure for back-propagation networks. Because, as probably the majority of our listeners would imagine, Google was really the company that kickstarted at artificial intelligence all over again, even way before companies like Facebook and so on copped on. Okay, this is what we didn't cover in the first episode. Well, not in great detail anyway. Artificial intelligence goes back easily as an computer-based artificial intelligence, goes back easily to the 50s and 60s. Flawed artificial intelligence goes back even way further.
Who's flawed?
Like the attempts to breed certain politicians who had strange ideas, and the rest is pretty much history. But we won't go into that because this is not a history podcast, but rather an open
certainly not a political one. Well, I don't know. It's debatable, I guess. There is a certain amount of communism support here. Anyway, carry on.
Absolutely. Yeah. Anyway, so in the 50s and 60s, especially North American scientists had the idea of, well, we have computers now, so modeling a human brain can't be that difficult. So speech recognition and image recognition and such things are just around the corner in the 50s. So they developed beautiful programming languages like Lisp and other functional approaches with the idea actually to build the foundation for something called artificial intelligence. The trouble is that the existing hardware at the time didn't quite live up to their expectations. So this is the reason, if you take a close look at the history of artificial intelligence, the whole thing entered a hiatus or a hibernation period or whatever you want to call it in the early to mid-70s. And of course, there were kind of wake-up calls in between. 90s tried to revive the whole thing in terms of, there was a company called Nuance that tried to use artificial intelligence for speech recognition, but these were kind of isolated blips. Because even then, the hardware wasn't really up to scratch to cope with the computational demands of artificial intelligence. Things really changed when a little unknown search company called Google entered the stage in the mid-2000s. Because, as probably we all know, Google is not necessarily about hardware, but rather the intelligence running on top of this hardware, as in doing software that is able to massively parallelize algorithms running on cheap hardware. That's exactly how they did their first search engine implementations. You'll see this actually if you take a look at their base infrastructure technology, like Bigtable, like Big File System. It's all published. You'll find the links in the show notes. The idea behind this is actually that they come up with software that took into account that hardware is not perfect. Hardware can fail, but the real intelligence is actually in software.
Well, you say that, but Google did develop the TPU, right?
That came later.
Yeah, but the notion of cheap commodity hardware. Anyway, carry on.
They deviated from this part of righteousness.
Change their mind.
But these are commercial implications, which we're going to touch in a minute or two. Anyway, to cut a long story short, the idea behind the initial Google version 0.9, if you will, of searches and Brian's invention was actually to do it with intelligent software. You'll see this in the initial implementations. They had the foresight to imagine file systems that are able to cope with petabyte of data, because the file systems at the time didn't measure up to these expectations. So they simply sat down, not the two of them alone, but rather the software engineers, and devised software that is able to power such large-scale systems and do it in a very reliable way. And that's exactly how they arrived at the technology that they have in production right now. And along their way, they discovered that there's this ancient technology called artificial intelligence that has been more or less sleeping for the last 30+ years because simply the hardware wasn't ready. So in addition to something called TPUs like TensorFlow processing units, we want to tackle this in a minute, they come up with the idea, okay, we produce software that is able to execute on standard hardware, but massively parallel. The idea behind the initial Google was, and I'm just using Google as an example, you buy cheap kit, but you expect this kit to fail. So you do software that is able to cope with failure. This is common lore. Google has never confirmed this, but they were able to cram more motherboards into a rack than and I'm talking about early 2000s now, than the then industry standard kind of specified in terms of thermal distribution, TDP. So because they expected some of the CPUs to fail. If that was the case, the software would notice that, and then some other parts would take over. Same thing for software same thing for artificial intelligence rather, because the real intelligence in artificial intelligence is actually in the software. So this is the reason why they took a close hard look at the foundational research that had been done in the 50s and 60s, for example, with regards to back-propagation networks, which weren't new about 20 years ago, but rather go back to the 50s and 60s, because that's exactly the point in time when people came up with this.
Indeed.
So because GPUs and CPUs only go so far, some of the Google engineers had this bright idea of, okay, similar to GPUs actually, we can do specialized hardware, especially if you want to deploy this in a cloud context, that is just able to tackle the TensorFlow algorithms that are implemented by TensorFlow, as in the library that implements backpropagation networks. Hence, the idea of a TPU, of a TensorFlow processing unit, was born that simply takes, or that simply implements the algorithms that are implemented in the library on the framework itself and executes that on hardware. That's the overall idea, achieving a massive speed up. In addition, and this is where the sweet spot is from a commercial perspective, in addition to these TPUs being able to deploy in cloud environments. Because this is where the money is. You can go into a hyperscaler, namely Google in that case, and simply deploy a farm of TPUs that then execute your Tensor algorithms.
Indeed. Other cloud vendors are available, but without TPUs, yeah.
Indeed. Well, Microsoft does something similar, right?
Well, most other people stick with GPUs, right? Because they are more easily available. Well, having said that, they're not so easily available these days, but in fact, they are quite scarce.
Gamers, if you're listening, stop buying them.
Well, I think the gamers would like to buy them, but they can't. Yeah, probably people from your cartel are buying them instead.
I can't really comment on this, actually.
No? Okay, good.
You see, crypto mining on GPUs has its limitations.
Indeed. So yeah, no, that's a good point. I mean, a TPU is really, an ASIC in short, isn't it? Not just like where specific, GPU mining is also programmed in hardware through ASIC miners are being considerably more efficient than GPU miners. Yeah.
But going back to these frameworks, is there anything else apart from PyTorch and TensorFlow these days? Because these are the two. Are there any other frameworks that come to mind apart from PyTorch and TensorFlow? Because these would be the two prominent ones, no?
Yeah. Well, before both TensorFlow and PyTorch became so popular, there was a whole variety of them, right? I mean, Keras being one of them, and Caffe and MXNet, and God knows how many there were. But they're all kind of very specialized, and the good thing about the adoption of TensorFlow and PyTorch is that, as with any open source project, you get the benefit of many people improving these frameworks.
Plus
or is there something else you had in mind?
No, not at all. I mean, the beauty is with these two frameworks, they just say they are open source, and depending on your hardware specification, you can pull them down, and you can run them. You can actually, if you want to do this, you can run them on an SOG on an SoC GPU. But then, needless to say, a dedicated GPU.
Well, you can run them without a GPU as well, right?
Yes, you can do that too, but don't expect miracles.
No.
But the beauty is, for the majority of something called domain-specific frameworks, pre-trained models are available.
Indeed.
So, Martin, what is a pre-trained model?
Pre-trained model is where someone has done the training for you. You mentioned the training phase earlier.
Yes, and why is that important?
Well, because it takes a hell of a long time or a hell of a large amount of processing power to do the training phase, because it's a very simple process, or simple. We went through it in episode 1, right? It's a sheer horsepower kind of scenario rather than anything intelligent training a model. So basically adjusting your weights and biases until you're going in the right direction and reach your optimum for the model, which is done by doing many steps and doing gradient descent and so on, as we discussed previously. But yeah, so pre-trained models are great because they give you, a lot of pre-processed training in the box.
And going back to the GPU or kind of parallel processing in general, any idea why tensors were chosen as the main instructions for these networks?
Well, tensors aren't instructions; they're more the data structure.
Sorry, not instruction, but abstraction.
Abstraction, right? Well, because it maps. If you look at your neural network layers, they are arrays of numbers, right? So, which is essentially a tensor.
Indeed, but the beauty with tensors is actually that you can decompose them into simple arithmetic instructions, which you then can parallelize on different cores in terms of GPU cores or CPU cores.
Mm-hmm.
Because if you take a look at how a matrix is multiplied with another matrix or a vector, most of these computations can be done in parallel. Only if you are at the reduction phase, to use the simple example of a MapReduce algorithm, you actually have to consolidate this using a single core.
Mm-hmm.
But leading up to this, you can parallelize this easily on different cores. And this is the whole idea behind frameworks such as TensorFlow as well as PyTorch, to decompose these tensors into independent arithmetic parallelizable instructions, so that you can use the full computational power at your disposal to give it a crack.
Yeah. So, do you know why these two frameworks are now the most popular ones?
I reckon it's evolution, right? Many people saw the advantages and simply used them in their projects. Lua or not.
Well, this is I mean, I think this is why the rise of PyTorch has come. It was obviously came out after TensorFlow, but it's pretty much equal in popularity these days, because the language of choice for most data scientists, whatever you want to call these people, is Python, right? So it is a fairly natural fit, therefore. I mean, you can obviously also use the Python interface to TensorFlow, but
yes, indeed. Full disclosure, of course, there's a whole episode on Python in last year's back catalog of something called Linux Inlaws.
Okay.
In case you're wondering about this hipster programming language called Python.
Yes, indeed. For those of you not using it. Yeah. So, other question I have for you is, why is there a what's the difference between TensorFlow 1 and 2?
Check out the changelog, I'm tempted to say. No, Martin, I wouldn't call myself an expert on TensorFlow. So if you have the answer, go for it.
Sure. Well, it's quite a significant difference between TensorFlow 1 and 2, and it's really that TensorFlow 1 was imperative programming, symbolic programming. So whereas PyTorch has always been from the start built that way. So they're both converging to the same thing, but there's a big difference. So if you're ever starting with trying to build your own applications with TensorFlow, and you come across TensorFlow 1 and 2, it's quite a significant difference in the way the two work. So it's worth noting that one is pretty ancient, but there's a lot of examples, implementations out there on one. Why don't you explain the difference between imperative and symbolic programming, Chris?
Imperative programming would be like BASIC or COBOL. You tell the computer exactly what to do and how to do it. And symbolic programming would be much more like functional programming, i.e. a functional programming language would understand lists, atoms, and the relations between them.
Yeah, what about the execution element of these two different ways of programming?
I think CPUs play a major role in this.
Well, it's commonly familiar with the term eager execution.
I'm not.
Okay.
This is the reason why we have highly paid experts on the show like Martin
It
Visser.
sounds like it.
Give it a crack, Martin!
I thought you were quite into your programming paradigms, but there we go. Okay, fair enough. I thought you would probably be happy explaining this one, but I can do it for you.
I think I've done enough talking on this episode, Martin. Give it a crack.
Okay. So, I mean, you know about...
that I can correct you if you're wrong.
I see. Okay, so if we think about any kind of program, right? We have lines of code, and in an imperative programming language, they are executed in sequence as and then, whereas in a symbolic programming language, we have a compilation phase, right, where the most optimum execution of that representation of the functionality is built, right? Make sense?
It does so far.
So that was the, but it's quite a, so TensorFlow started with the symbolic approach, saying, because obviously there's advantages to this, right? Like, yes, no?
I'm listening, Martin. I'm listening.
Okay, I was just wondering if you wanted to fill in the blanks.
No, that's okay. I've done enough filling in the blanks for one day anyway, so no worries.
Oh, okay. Oh, I just wanted to make it a discussion, but that's okay. Or a two-way explanation, but it's fine. I can do it if you want to.
Sometimes, Martin, I just listen in awe. That's okay, no worries.
Well, it makes a change.
It does indeed. Give it a crack, Mr. Visser. Give it a crack.
Right, where were we? So, yeah. Okay, so
symbolic and stuff.
Yeah. So right. So if you think about I don't know, some people consider the execution of a program to be a graph, right? And so you basically build with a symbolic programming language. The graph is built compilation time and is fixed, right? So whereas in an imperative programming, it's done. Every step is done at the time as described by the programming language. So the advantage of this model is that it's very efficient, right? Your symbolic implementation, because the compiler is trying to find your most efficient way, and you can reuse your memory space and all sorts of excellent stuff benefits you get from that. Which is all well and good if you have if it's bringing it back to neural networks, or if we think about models, then if our model is fixed, then that's great, right? Because you can run it as many times as you want to. It's optimized to the nth degree and so on, and you can parallelize it however many ways you want to. However, if you have a model that's dynamic or self-adjusting, then that doesn't work with a static kind of execution graph, right? So so Python from the start did that dynamic approach, and with TensorFlow 2, they have adopted that as well. So, so if you're looking at, or if you're using the methods that are available in these frameworks, then you're probably not too worried. But if you are going to develop your own models, or even adapt the models that come with some of these frameworks, then you may want to be aware of this. I mean, it's something that I came across with TensorFlow, that the TensorFlow 1 and 2 are hugely different. Not that I'm an expert by any means, but I have certainly played with it a little bit, and it's similar to what some of my colleagues have been saying as well. So it's but yeah, now both have adopted the same method. So they're both doing the same thing. It's just TensorFlow started somewhere else. So yeah, that was the end of that episode. But yeah.
Oh, interesting. Because I thought that TensorFlow was mostly written in C++.
I don't know, to be honest. I don't go into the low level.
No, I mean, it's interesting because C++ is a compiled language.
Yes. Yeah. Yeah, but if it's more the okay. Well, maybe we should do an episode of the different levels of the different steps between implementing TensorFlow and PyTorch. But actually, it doesn't matter anymore because both have adopted the same eager execution now. So from that point of view, yeah. Because this is why they changed TensorFlow, right? Because they couldn't do dynamic models because everything, once it was compiled, it was fixed, and so it couldn't adapt itself to, or it couldn't be built to be adaptable.
So TensorFlow would be the first AI framework that does what's the word I'm looking for? Just-in-time compilation of self-modifying code.
Yeah, sounds good.
You heard it here first, people.
Well, that's artificial intelligence.
If you're listening, Google, if you're listening, the email address is sponsor@linuxinlaws.eu.
Well, you say this, but you know about we have a future episode on
Google. Certainly, we do.
Well, I thought the current episode was on Google.
No, Martin, you're wrong. The current episode is on back-propagation networks. Sorry,
frameworks. Sorry, okay. I thought it was episode 1. Anyway, what were we saying? Yes, so the one of the upcoming episodes, we're going to talk about a quite popular, an implementation of a model which is raised some waves in the community and press because of its abilities in terms of language.
No, I'm listening in awe, Martin, as usual.
Well, I mean, if you look at adoption, okay, Google is the biggest user of TensorFlow, right? But
when they came up with the stuff.
Well, you would hope they were the biggest user. But if you look at the adoption of PyTorch, are you familiar with a company called Tesla?
They make cars, among other things.
Cars and batteries and all sorts of stuff like that, and rockets that tend to...
But I think they just borrowed the name from some really famous physicist.
Yes.
Long gone, of course, but that's a different story.
Well, yeah. Family Tesla, if you're listening, you've got a pretty good court case on it.
Tesla, don't try. Just don't forget about it. Don't even reach out to Martin for marketing consulting. That would be money down the drain. To use a technical term now.
Marketing,
sorry, Martin, go ahead.
Let's not discuss marketing. That's not going to go well, is it? Where were we? Yeah, so a lot more companies outside of Google are, not outside of Google, but are contributing, supporting PyTorch, right? And its popularity along the research community is, I think probably equal, if not greater than TensorFlow these days.
Is it still really a competition between TensorFlow and PyTorch?
Well, I find it a bit curious that why do we need two, right? It seems a little bit of a wasted effort. So there must be some differences. Otherwise, one would become more prevalent than the other.
If current law is anything to go by, there are more frameworks than just these two dominating ones.
Yes, but that's kind of like, why bother, right? If you have these two that are 7 years in the making, then why do you need another one? I mean, the functionality that they offer are obviously in the fields of, computer vision, NLP, et cetera, et cetera. So, what would you be missing from those two frameworks to start your own?
I mean, frameworks are pretty much like cars or women, right? Or men, for that matter, before the PC police gets to us. Cars get you from A to B, and women make you happy, or men, for that matter. Don't get me wrong, but at the end of the day, they have four wheels. Cars now. The PC police will probably shoot me for this remark, but don't worry about it. And men and women do have hairs, arms, and all the rest of it. There are, of course, differences. Cars, for example, have different engines. Men and women have other differences. We won't go into the details, but you get my drift. Same goes for back-propagation networks. At the very end of the day, they are pretty similar. On the surface, they may differ a lot, but at the end of the day, they just are about mostly pattern recognition and what comes afterwards.
Yeah, sure. I mean, we were going to have someone on the show on these things, weren't we? But
for logistical reasons, that didn't happen. No.
Yes, but it's. I mean, if you think about it, why do you start contributing to one or the other? Which would be an interesting question for me. It's you have a problem to solve. Fine. TensorFlow hasn't solved it or doesn't provide options to solve it. PyTorch doesn't have options to solve it. So why do you choose one or the other to start contributing to?
Because you like Lua?
Maybe. Where does Lua rank on the popularity of programming languages? Or is it
76 point something on the Chobi's index or whatever. Chobi, of course, you'll find the links in the show notes. Or of course, the Danish company. I think it's called The Importance of Being Earnest or something.
That's the Stack Overflow survey, isn't it?
No, Chobi is something different.
No, that's the one I was thinking of, but is it not on there?
No, Stack Overflow actually ranks Lua at position number 17.
17?
75.6, yes.
Ooh.
Oh, yeah. Of course, the routers and OW and OpenWRT helped a lot.
Yes. Fair enough. Okay. Right, sorry, to diverge. Yes, what else would you like to cover?
Well, that's pretty much it, all right? Maybe a teaser for the next part of the 27-part episode miniseries, whatever.
Is this specifically for Bob, or is this following on from the current modeling?
No, I mean just what we do want to cover during the next for the next episode. Now that we have a very good grasp on the basics, anyway.
We can do another recap next time. Yeah.
Podcast episodes can only go so far, people. Needless to say, we only scratch the surface here. Yes. And needless to say, we did not go into the mathematics of this, because this is not what Linux Inlaws is all about, because that will get very quickly very complicated. We leave,
wouldn't it? Yeah.
Yes, blatant cross promotion. We leave the mathematical details to a podcast called the Grumpy Old Coders. We had them on the show. Oh. Yes, we had them on the show quite a few episodes back. They are legacy people, mostly concerned with Windows.
Legacy people. Right? What's a legacy person?
People that are old. The hint is actually in the name. Grumpies, if you're listening, you're welcome back on the show at any time, because I thought it was just a hilarious episode and we really like you. But anyway, doesn't matter. Okay, jokes aside. Yeah, the next episode will be about the practical applications of these kind of two foundational frameworks like PyTorch and TensorFlow. We will cover the domain-specific implementations like Keras and so forth, based on PyTorch and TensorFlow. And as I said, needless to say, this episode is not about the finer details like mathematics and so forth, because that would fill another 2 or 3 episodes of this miniseries because it's just very complex, and that's the reason why
Well, it
most
doesn't
people
work so well
actually.
without a blackboard either, does it?
Yes, and that's the reason why actually most people would just use these frameworks rather than kind of re-implementing these frameworks themselves.
Indeed.
Because all the fancy math stuff is abstracted away from you.
Mm-hmm. That's the beauty
Bottom
of
line.
computers.
Yes.
And levels of programming languages. And
yes. And before we close out this episode, of course, Martin, yes, we do have
feedback.
We do have to do feedback. Yes.
Feedback. Yes.
Yeah, a certain Mr. Ken Fallon of HPR fame, yes, indeed, writes in to say, I always thought that artificial intelligence is misleading. Ken, you're absolutely spot on. Artificial programming would better describe what's going on. Yes, to a certain extent. Artificial intelligence, yes, of course. Ken, brutal teaser, Ken will be on the show very shortly. For a couple of weeks' time, yes. Okay. And of course, Ken is one of the beautiful people behind something called Hacker Public Radio that we still use as our main hosting platform for all the episodes, kids out there. So, yes, artificial intelligence as a term is somewhat misleading. I grant you that, because
this is where it comes down to people's definitions or interpretation of those words, right? Perhaps.
Well, at the end of the day, the way we tackle artificial intelligence these days is more or less like programming, in terms of algorithms being implemented by a computer.
Yeah, but yes, okay, the two are fairly synonymous at the moment. But it doesn't mean that artificial intelligence can't be implemented in a different way, right?
Exactly. If you would decouple artificial intelligence from computers, fine.
Mm-hmm. Indeed. Agreed.
But we're not.
No, because we are that kind of podcast.
No, we're that kind of people. In terms of people.
That too. Yes. Yeah.
In terms of people simply using computers to do artificial intelligence programming, and so Ken is absolutely spot on.
Yes. Yeah. Mm-hmm. Yeah. I mean, I'm sure someone will come up with a biological artificial intelligence solution at some point. But,
or actually putting some other non-von Neumann hardware to the game, or something beyond computers. Yes. Like molecular biology or something, like not necessarily brains, but the thing that comes afterwards. Another topic for another episode.
Here's a question for you: is intelligence limited to people?
No, it certainly is not.
Well, there you go then.
You have it to a very limited extent also in politicians, for example.
Ah, yes, of course.
And other people are anything to go by. Sorry, and other beings are anything to go by.
Well, like people in marketing, or no?
I wouldn't go that far, no, but it's a different story. And with that, we have not only reached the end of the tether,
indeed,
but also the end of the show, I suppose.
Yeah, I think so.
So, Martin, see you on the other side for another episode on artificial whatever. And of course, for the hipsters out there, that would be artificial space full stop star. Sorry, plus being a complete regular expression now.
Excellent.
Martin, and with that, we're gonna call it a day and see you soon. This is the Linux In-Laws.
You come for the knowledge,
but stay for the madness.
Thank you for listening.
Skynet is proud to be a sponsor of this episode on neural network infrastructures. Forget the malarkey about Google being behind TensorFlow. As every Terminator worth his or her salt can tell you, we are behind it all. Google is our invention too. The rest is marketing. Like this cute little voice making you forget that Skynet was once this evil empire trying to change the world.
If you can change, so can we. This podcast is licensed under the latest version of the Creative Commons license, Tab Attribution Share Alike. Credits for the intro music go to Blue Sea Roosters for the song Salute Margot, to Twin Flames for their piece called The Flow, used for the segment intros, and finally to Celestial Ground for their song Sweet Justice, used by the Dark Side. You find these and other ditties licensed under Creative Commons at Jamendo, a website dedicated to liberate the music industry from choking copyright legislation and other crap concepts.
You are currently the only person in this conference.
The only person in this conference, but is this... Oh, I'm going to end the session and start a new one. Hello? Hello. Okay.
Yes, that apparently works now.
Aha.
Do you know what a quantum torus recursive neural network is?
Well, I know what a torus is. I'm just trying to work out what a quantum torus would be.
You deviate from standard von Neumann architectures and you throw in qubits and then you pretty much have it.
Okay.
Like your neural networks basically that are able to tackle n space, p space, NP space instantaneously, more or less.
Yeah. Well, you got to start somewhere.
Well,
This means
I
you
don't
can
know.
write the programs for when this stuff actually is working sometime in the future or not.
There's this DeLorean car.
Yes. Well, that wasn't a success, was it, really? Apart from the movie, yeah.
It was probably before its time, so...
Well, no, it was made in Ireland by a dodgy crook. This was the issue with it.
Martin, if you say
If
so.
you're listening, whatever your name was, DeLorean guy, you're a crook. Yeah.
Well, I think he produced at least 6 of them or something.
Well, it was all funded by the government or by the EU, even possibly. Yeah.
That was Northern Ireland.
Because it was built in. Yeah, indeed. Yeah, it's probably EU funded.
Okay.
I think you spend too much time in SEAL, don't you?
Thank you.
You're welcome.
Unlike other people.
Yeah. There was a question from a certain Bob. He was asking, when you're referring to models, is that similar to the pictures you're sending around usually? Or do you refer to
No.
a different type of model?
Quite different models, actually.
Okay, well, there you go, Bob. Yeah, thanks for answering, Bob.
Bob, if you're listening, there are quite a few different categories of models. And the model you're probably looking for, unfortunately, is not part of the show.
I thought you were working on that one.
No, Martin, I'm not.
Okay. Fair enough. Right, sorry, carry on.
You've been listening to Hacker Public Radio at hackerpublicradio.org. We are a community podcast network that releases shows every weekday, Monday through Friday. Today's show, like all our shows, was contributed by an HPR listener like yourself. If you ever thought of recording a podcast, then click on our contribute link to find out how easy it really is. Hacker Public Radio was founded by the Digital Dog Pound and the Infonomicon Computer Club and is part of the binary revolution at binrev.com. If you have comments on today's show, please email the host directly, leave a comment on the website, or record a follow-up episode yourself. Unless otherwise stated, today's show is released under a Creative Commons Attribution Share Alike 3.0 license.